A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi, we have discussed the preparation and characteristics of one of the important non-metallic compound, that is ammonia. So today we are going to discuss another important non-metallic compound, that is sulfuric acid. Sulfuric acid is a chemical of utmost importance in the industry. Let us see what are the important uses of sulfuric acid. Manufacture of fertilizers, refining of petroleum, manufacture of paints, manufacture of fibers, manufacture of explosives, manufacture of other chemicals for dehydration. Now you can understand why sulfuric acid is called the king of chemicals, right? Let us see what are the physical properties of sulfuric acid. Colorless, high viscosity, highly corrosive, denser than water, dissolves in water. Now let us discuss the industrial preparation of sulfuric acid. Sulfuric acid is industrially prepared by the contact process. Let us discuss various steps in contact process. Sulfur is burned in oxygen to produce sulfur dioxide. S plus O2 gives SO2. The sulfur dioxide thus formed is allowed to combine with oxygen in the presence of vanadium pentoxide as a catalyst and 450 degrees Celsius to produce sulfur trioxide. 2SO2 plus O2 reversibly gives 2SO3. Sulfur trioxide is now dissolved in concentrated sulfuric acid. SO3 plus H2SO4 gives H2S2O7. The product thus formed is known as oleum. Sulfuric acid is produced by dissolving oleum in water. H2S2O7 plus H2O gives 2H2SO4. Sulfuric acid is formed also by direct dissolution of sulfur trioxide in water. Still, sulfur trioxide is not directly dissolved in water. Why? The dissolution of sulfur trioxide in water is an exothermic process. It may turn sulfuric acid initially formed into fine fog-like particles, that is smog, which will hinder the further dissolution. That is why sulfur trioxide is dissolved in concentrated sulfuric acid to make oleum. Okay? Now let us complete the flow chart given here. S plus O2 gives SO2. 2SO2 plus O2 reversibly gives 2SO3. SO3 plus H2SO4 gives H2S2O7. H2S2O7 plus H2O gives 2H2SO4. Now we will discuss what are the chemical properties of sulfuric acid. Take 5 ml water in a test tube and slowly add concentrated sulfuric acid in it. Heat can be experienced when we touch the bottom of the test tube. That means the reaction is exothermic. Look at these pictures. Which one is the correct process? First one, isn't it? That is, while diluting sulfuric acid, the acid should be added to water in very small quantities, stirring it. If we add water to acid, it will result in spurting and may cause burn to our body as a reaction is highly exothermic. Now take some sugar in a watch glass and add few drops of concentrated sulfuric acid. Let us see what happened. A black residue is left in the watch glass. What may be the black residue? Let us see the equation of this chemical reaction. C12H22O11 concentrated H2SO4 gives 12C plus 11 H2O. In this equation, what are the constituent elements of sugar? Carbon, hydrogen and oxygen. And carbon is the black substance formed here. What is the ratio of hydrogen and oxygen in sugar? 22 hydrogen and 11 oxygen, that is 2:1. What is the ratio of hydrogen and oxygen in the product formed? It is also 2:1, right? Here sulfuric acid absorbed hydrogen and oxygen present in the sugar in the ratio corresponding to that of water. So, concentrated sulfuric acid has the ability to absorb chemically combined water or hydrogen and oxygen from substance in the ratio corresponding to that of water. This process is known as dehydration. Concentrated sulfuric acid is a strong dehydrating agent. Let us discuss more experiments to confirm the dehydrating nature of sulfuric acid. Drop a few drops of concentrated sulfuric acid on a cotton cloth. What can you see here? The cotton cloth gets burnt. Here, sulfuric acid absorbed hydrogen and oxygen from cotton, that is cellulose, in the ratio corresponding to that of water. Now, add concentrated sulfuric acid to a watch glass in which copper sulfate crystals are taken. Here, we can see that the copper sulfate loses its color and become white powder. What may be the reason? The blue color of copper sulfate is due to the water present in it. When we add sulfuric acid to copper sulfate, the acid absorbs the water content present in it. As a result of that, copper sulfate loses its color. What will happen if we add some water into it? Copper sulfate will regain its blue color, right? So, we can understand the dehydrating nature of sulfuric acid from these experiments. We shall discuss more reactions of sulfuric acid later. Bye.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the learning app.